I'm going to show you that details of that book in the end. But, most important aspect is corrosion is an ongoing challenge. I don't have to elaborate about the corrosion more, the safety and the productivity and the downtime, which we all know. So, my lecture I have divided into two simple aspects. One is talking some fundamentals of corrosion and what could be the preventive actions for those small aspects. And the other aspect is a philosophical aspect, by which how we can change our mindset to solve the problem. Because we have done enough of what we have done, it is important that we change our mindset. So learning from the past is where the world has built all major standards, all major achievements and all major aspects. They say that history, if you do not repeat, is a success. Having said this, three famous examples I want to talk to you guys. One, a very famous example of Titanic ship failure, which we all know. When the ship struck with an iceberg, it failed in a brittle manner. The engineer learned that metal becomes brittle at low temperature. The tank collapsed, and they understood that tank also needs certain specification, certain standards. So, and the standard came after the first collapse of the tank. The Tacoma Bridge, which failed because of the vibration, and the vibration analysis started coming into the picture. So these aspects taught world made standards. India only followed it. It is India's time to make standards because we have the highest database. Highest amount of plants are with us, highest failures we do, and 3 applauds for our ability to solve those problems because we always put our plant back in 2 days. I have always seen. So we can fix problems, but now this new time we want to prevent problems. You are with me? So in order to do that, we have all these implications where asset longevity is something which I want to work for our country because somebody told that the foreign products are cheaper in our country, than our country product. You cannot produce cheaper power or you cannot produce cheaper manpower because this country has its own standards. But what we can improve on productivity is continuous production. So failure without production will also reduce the cost of the product. And hence, this is the time we all will have to focus as a country to avoid failures. So, can corrosion be predictable? Now, this is something very interesting. I always believe firmly that corrosion can be predictable. And when corrosion is predictable, you can prevent it. So, you have to only understand all damage mechanism. Now, this is a new word and terminology. We all learned 8 forms of corrosion, which I am going to show you those 8 forms of corrosion, just to brush up your mind, so that the right thing can go in your mind. But the idea is that it can be prevented. Now, these are the typical 8 forms of corrosion. When we start with general corrosion, we start with pitting corrosion, then we have crevice corrosion, we have intergranular corrosion. So, once you now know, many people, corrosion is corrosion. For people like me and Amish Jani, corrosion can be divided into more than 70-75 types. So now when you know those finer points of corrosion, you can definitely prevent it because mechanistic aspect is very important. When you go to a doctor and some doctor gives you 5 medicine and one doctor gives you only 1 medicine, that one medicine who is giving, that doctor knows the mechanism of your failure, mechanism of your problem. And hence, in today's time, we all must go into the fundamentals of damage mechanism. So I want every chemical process industry to have an expert, not a corrosion expert, but the damage mechanism expert. This is the first philosophical change which I want in our industry. Once you have a damage mechanism of expert inside, he will decide that, okay, I want the material with only 22 chromium and not 21.5 chromium. And there he will be able to talk to your purchase guy. I have many times suggested earlier Sandvik material and we have solved their problems also. So you people have done wonderful services to the chemical industries. I have utilized and recommended your material only to benefit my clients. And this is the journey which will go on and on. But the knowledge is something which is going to change the present philosophy, how we operate our plant. And hence, This is very important. Very quickly we go to, different corrosion in a very brief manner. Uniform corrosion is like, which we talk about all structural steel corrosion, where the thickness of the material goes down. So you only put a barrier coating, or you try and improve the environment, which is also not that easy, but barrier coating will solve your problem in that case. Then other aspect is galvanic corrosion. Many of you must have seen that when your copper tap attached to your steel pipes, there is a corrosion at the junction, right, in home. So when you convert it to steel or stainless steel, that corrosion is prevented. So when you have a dissimilar metal with high potential difference, so this is something which industry knows. So many times people try and keep two metallurgy same, where noble metal is protected and the less noble metal is getting corroded. So this is something very important to understand. Pitting is again a problem which everybody knows. So any metal which provides the protection either by producing passive film. Suppose you take a stainless steel produces oxide layer, chromium oxide layer. So that is its preventive mechanism. If you take a boiler, the formation of magnetite layer is a defense mechanism for further corrosion to prevent. So this chloride, it penetrates the skin of the stainless steel, or oxygen can penetrate the skin of the carbon or alloy steel, and it gives you localized damage. This is very dangerous. So I have seen many times people wants to upgrade the metallurgy instead of working on lowering the chloride. Now here two aspects you have to understand. Stagnant water is very dangerous. So if you avoid stagnant water, I have seen many people after hydro test in the heat exchanger, people leave water as it is. So at most of the places the water remains. Now this knowledge, this is more of convenience, I mean, I'm sure many of you must have experienced, your wife tells you that don't put the wet towel on the bed. And then what will happen. So same concept occurs into the industry where we remain water in the equipment, and which is very dangerous. So this is how you can prevent them. Intergranular corrosion in stainless steel and nickel alloys is very, very problematic. Here I am going to give you, I'm not going to tell you right now about this austenitic stainless steel. Everybody knows that chromium carbide precipitates at the grain boundary and the chromium depletion zone occurs. But this problem is also there in Inconel 600 material. Inconel 600 material recently has experienced intergranular corrosion in service or during welding in a severe manner. When you think that when you are spending so much in nickel alloys are equally susceptible to, so there you have to give stabilizing treatment at 715 degrees centigrade, which very few people knows about this. So when you buy any material of Inconel, if you give stabilizing heat treatment, it will give the life 2 times, 3 times. And it is said that when you want to use Inconel, now it is also research has told that nickel alloy, when you higher the nickel percentage, better the stress corrosion resistance. I think you have heard about it, right? The new research is telling that nickel has a particular percentage, and after that the SCC resistance decreases. So the base resistance comes for Inconel 800 material in comparison to Inconel material, because Inconel has more than 50% nickel, where Inconel has around 25 to 30% nickel. So these kind of higher the material, better the corrosion resistance is a myth. Every material has its potential environment. And प्रवीण जी है यहाँ पे? प्रवीण जी, क्योंकि ये लेट हुआ है चालू, तो आप मुझे बताना कि कहाँ, क्योंकि I have lot of information, I might overspeed the time. Just let me know. Yeah. Then erosion corrosion is another damage. So now here the other day, in just a week before, I had talked this in one of the online conferences, this concept. But we have a habit of naming the failure and how it can create problems. In one industry, I had gone to do the investigation, and I went to their highest boss, and he said, Mr. Haribhakti, we have a pitting problem, and we have done this situation. Even we have called the OEMs, my problems is not solved at all. Then I went, everybody talked about pitting, but I told everyone that, okay, let me analyze the root cause of the pitting. I cannot say that it is not pitting. I took the sample in the laboratory, and I found out that it is cavitation erosion in the heat exchanger. It was exactly looking like pitting. So everybody gave wrong direction and they think that there is some ghost problem which has come to this reactor. I asked them to reduce the flow rate at the initial stage or put some barrier so that the uniform flow can go in the tube, lamellar flow, and the problem of cavitation was avoided. So don't name the problem. It is very dangerous phenomena which is happening in the industry. That is why I said I feel there is a need for damage mechanism expert in the company itself. And I am very proud to say that TCR has taken the lead in generating those damage mechanism experts. We have training institute called Evolve. Evolve by TCR, because whatever I have learned from industry, I want to give back in form of knowledge. So TCR, a lot of, SRF and all those people are taking our services quite often. So I request, if you want to generate a damage mechanism expert, we have a crash course on damage mechanism. And that will give a lot of wealth to your company. Having said this, selective leaching is another form of corrosion which is happening into condensers or when the copper alloy tubings are used, where zinc and other aspects are getting leached from the copper. And then, we are spending huge amount of money in these damages. So selective leaching is one aspect. Stress corrosion cracking, I'm sure you must all have heard about it. It is a combination of the stress, the environment, and the susceptible material. So I am going to give you 2-3 examples which are very unique in themselves. So you will also come to know that what kind of improvements are needed. Then we have hydrogen related damages. This is the least understood damage in the industry. Hydrogen in the metal can go from melting of the metal, from welding, from plating, from corrosion, or during operation. So people are not able to differentiate between which hydrogen has created what problem. And there are very serious, we have taught people 2 days only for hydrogen damages, which is very serious threat to industry, where you must have seen a lot of disasters have occurred in the industry. A lot of failures and a lot of big issues. You may not have one incident in the entire year, but one blowing of one reactor or one blowing of one pipeline will put you into the list of the newspaper for wrong reasons. So you need to understand this hydrogen damage in very, very particular aspect. This is something which I want industry to understand. And another kind of damage which is recently observed since last 15-20 years, because I receive a lot of samples. It is microbiologically induced corrosion. It is like corona. The microbes, they secrete acids by taking the food of sulfate or some other oxygen or iron. When they eat, they secrete acids and those acids corrode. So this knowledge is very, very important. Especially most of the damages I have observed during hydro test. So those industries who have learned lessons, including Reliance, if I am allowed to speak this name because I want to share, they are taking a lot of precautions. And hence, we need to understand about these damages. So basically I am now going to take you to the practical side of the problem solutions, and then I'm going to give you the philosophy, how effectively, my intention for the industry, for TCR's intention for industry is to work with known failure history. We should know that this component will fail at this time. We should know that this component will create problem. And that knowledge base will allow you to take timely action. I cannot prevent all the problems because corrosion is a natural process. Like the human body which ages, metal has to corrode, given a chance. But you should know at what age you should retire. आदमी ने अपने लिए तो रिटायरमेंट कर दिया, पर इक्विपमेंट के लिए भी रिटायरमेंट एज है. और राइट रिटायरमेंट एज, कहाँ सर्जरी करना है, कहाँ इसको रिप्लेस करना है, वो जानना है. तभी आप प्लांट को 20 साल की सर्विस के प्लांट को आप 80 साल चला सकते हो. So this is how we need to do. There are so many damage mechanisms, my friend. So many damage mechanisms. And when these damage mechanisms, they interplay with each other, then so-called experts will not be able to solve your problem. Because if you have typhoid and jaundice together, both medicines are required. So here, so many kind of damages are there. When 2 or more damage mechanisms are operating in an equipment, you have to be very, very careful. So this is where the knowledge comes. Now I'm talking about our phosgene reactor. This is one of the plant which, and you know what is phosgene? Phosgene, the same gas which was released at Bhopal. I don't have to tell you the importance of this reactor, right? The problem when it came to me, we found out that this is a reactor where phosgene is generated, and if you look at the top, the fluid is entering at 95 degrees centigrade and which goes out at 110 degrees centigrade temperature. And there is a chlorine gas inside. Now this chlorine gas, there is a very thin line that it starts corroding at 105 degrees centigrade temperature. Below which it is not corrosive to steel or nickel alloys. Now this narrow, the design problem was at the top, if you see there is a stagnant zone because water outlet is on that side. So there is a stagnant zone. Can you see that? We asked them to shift the nozzle to the top. Now which material will prevent this problem? No material will prevent this problem. You have to understand the problems in a right perspective. So problem why people are not able to solve is because there is a material issue, there is a fabrication issue, there is a design issue, there is a process issue, and hence people blame each other with whatever information they have, genuinely or ignorantly. I would put more my finger on ignorance. And hence, we have opened an institute to teach people in this subject, which is extremely helpful for our country, for our safety of our people, and most important, for the productivity, because we want to beat other countries in production. You are with me, right, on this? So, having said this, another example, the heat exchanger tubes were perfectly manufactured, which was 304 material from a very reputed supplier. And these heat exchanger tubes were used in the plant after 2 years of storage. I think, sir, you talked about the storage when you said that storage also corrosion occurs. This is a classical example. The packing in 2 years, because see what happens, the truck people, when they unload in the plant at the night, they only release the boxes. So all those protections which is made beautifully by the manufacturers, they go haywire. And when they are stored in upper, there a lot of water and mud goes inside. This is a very story I have seen at many places. And people then blame the tube manufacturers. So, same case, such severe pitting of a good material was happened. I would say this is a murder of the material. This is not even gone to the plant. It's not put into the service. So case came to me, we did identify and we found out that there is a typical tunnel corrosion. Can you see it in scaling electron microscope image? There is a tunnel which is formed. This is a typical indication of microbiologically induced corrosion, MIC. So this was MIC. They confirmed that it was lying in open. As I told you, since 15-20 years, our water have got these bacteria which is more dangerous to material. So you be very careful either during hydro test of your plant. That knowledge must exist. Chloride knowledge has already come. People have utilized the low chloride content for hydro test. But MIC knowledge is yet to come into industry. And when somebody has faced problem, you don't learn by facing the problem. You please ensure that somebody has already faced the issue. So this is what I say, lack of application of existing knowledge. And this is what, my agony is there. When I get failure sample, I don't learn anything now because we have done enough investigation. So this is where we want to go into prevention. Then we found out the EDS analysis and we found carbon, very high carbon there. Carbon comes from biomass of the bacteria. So, there are certain diagnosis technique. I'm not going to go into the details, but there are different characteristics of the corrosion you can identify for MIC. My point is made here, so I'm going to the next case. Now, this is a Borsing system, which is using for refrigeration. You all know that, right? So, the normal carbon steel was failing from the weld. And they did everything what they could. Failure did not stop. And that problem came to me. It also gave me sleepless nights. Because carbon steel will never fail in the treated water. In the form which is filled normally in refineries. Carbon steel, I have seen many failures in refineries, but not with the water. So we found out that carbon steel can go to, can you see, EDS gave me the hint. EDS is a local chemical analysis. And we found out that molybdenum is very high, up to 4%. and we asked them that molybdate treatment was done. Now molybdate treatment is anyway people are not using it because of the safety reasons, because there are regulations, but those who are using molybdate, you can change it to chromate based inhibitor. Molybdenum is supposed to inhibit the corrosion. These molybdate gave corrosion, and it is capable to do stress corrosion cracking. Now this is not written except in one or two research paper. This is not written anywhere. So sometimes we feel that corrosion is not, it is my lack of knowledge gave me a lot of time, then my knowledge increased, I gave the right solution, and the problem, when the molybdate which was used as inhibitor was changed to chromate based, then problem is solved. No failures. So these are very unique cases which I am trying to talk to you guys. So given these three examples, this is the book which I was talking, which has been published by American Society of Metals, which has about 200 plus cases of the boiler tubes. This is published in 140 countries. And once the book got a great reference from the world over, they asked me to change the handbook chapter, which I feel very proud as Indian, that the failure investigation of boiler components is now in the Indian company name. And I am extremely happy to announce this, that this is now in a handbook of American Society of Metal. So this is something which I wanted to talk to you. Now I'll take another 2 minutes here for giving you how we can manage this entire corrosion. So given this background in the mind, you all agree with me that lack of existing knowledge only create failures. So what we should do, we should start recording our incidents in terms of one column. We have to add about damage mechanism. In all Excel sheet which you make a column of damage mechanism. Once you know the damage mechanism, and when you start knowing about it, you will come to know that whether you have to use right material, whether you have to use the right process, or whether to use right maintenance practice, or use the right approach. So we have made one software tool for industry called asset integrity optimization, in which all the equipments are discussed and identified for problems, and you will be given prescription for every equipment. Once it is done, you will have to follow those prescriptions based on our past experience. And of course, this is an ongoing. You may also give me some feedback where we can also learn. It's a mutual. I'm able to tell you because I have solved so many problems. That does not mean my learning stops. Learnings is always, we learn here. So now as a country, we have to come out from a database. We have to give a right solution. It's a system which we have tried to make to maintain our plant, our heat exchangers, everything, whenever we want to operate at our will. Thank you so much, friends.